Hi friends, happy morning. I Reshma welcomes you again to a session on database management system. So in today's session, I'm going to discuss with you about project and rename operation in relational algebra. In previous session, I have discussed about the concept of renal algebra. So where it is a procedural language and we can represent these in the form of a sequence of relations to form a relational algebra where order has to be specified and the result will be also a new relation. So this concept we have explained in detail in the previous session, and also we have observed the different categories of relational algebra operations. In previous session I have discussed about unary operators that to be in project operation. In today's session, I am going to discuss with the project operator. In previous, I have discussed select operator. So now in current session, I am going to discuss with you the project operator. Now the project operation. So here, the project operation is used to select certain columns from the table and discards other columns. Only some columns to be selected based on user requirements, other columns has to be discarded. So therefore here project operation it performs vertical partition of a relation. In select we have done horizontal partition. Here we perform vertical partition of a relation into two relations and the symbol used is pi of r. So pi is the project operation here. So here the pi symbol will be used to indicate the project operation and only the desired attributes according to user requirements. You can select only some of the columns, some of the attributes, and here result of the relation is again a relation, but the order of the resultant relation must be same. That is, the result of the project operation has only attributes specified in the project operation, and the order of the attributes which we are going to select, it will be same as the order which we have specified in the select operation. And here the project operation, what it will do, it will remove any duplicate tuples if it is present. For example, if I want to select name from student table, I want to select only the name column. If the name columns contains duplicate names like Ravi, available some 4 times, Ravi, and then next names will be Anam, Wafa, Raju. So now among these 7 names, Ravi appears more than 1 time, so it is duplicate value. If we want to display the name of the student, then it will remove those duplicate values and it will display only distinct tuples. And here, after applying project operation, in the resultant relation, the number of tuples will be same as original relation, that is, cardinality of the relation remains same, but the degree of the relation, it will be either less or equal to the original relation. That is based on number of columns you want to display. Only those many columns can be displayed. So minimum 1 column and maximum n columns can be displayed. So but duplicate tuples will be removed. For example, so now I want to apply project operation on the employee table. So like first I want to retrieve only first and last name and salary of all the employees. So how to write here? We need to write the pi list of attributes, name of the relation. So pi L name, F name, salary, name of the relation. Here there is no condition. We are no need to check the condition as whether the condition is true or false. So there is no condition here, just we need to specify which columns to be selected. This is unconditional operator. Without any condition we are retrieving the columns if the columns are valid. So see here, just it has selected L name, F name and salary columns. So then next, as we said, the project operator, it eliminate duplicate values. For example, I want to display D number from employee table. So now here in employee table we have 8 tuples. In these 8 tuples, department number 5 available 4 times, 4 3 times and department number 1 time. But while displaying the department number, while retrieving department number from employee table, it will not display department number 5 4 times, 4 3 times and department number 1 we have only 1 time. So it will display each department number only 1 time. So result will be department number 5 4 and 1. So this is one of the very good property of project operator operation. So it will treat relation as a set. So set is an order collection of unique elements. If duplicates are there, it will be eliminated. So here pi, it treats relation as a set. So one more example we have, retrieving salary and D number. Again, if salary and D number is same, if both values are same, then only it will remove those as duplicate values. So total now here among 8 tuples, it will remove those tuples whose salary and D number is same. So 3005, is there any value with 3005? No. 40,005, is there any value with 40,005? No. Then 25,004, is there any tuple with 25,004? Yes. Seventh tuple has 25,004. So now instead of displaying 25,000 department 4, it will display only once. Then again there is no other tuple which is having salary and D number same. So like this, pi, it will delete or it will eliminate duplicate from single column or multiple columns also. Single column means it has to take only one value. More than one column, if there are 2 columns, both column values should be same. If I have 3 columns, then it will say consider it as duplicate only if all 3 columns have similar values with other tuples, then only it will treat it as duplicate. So now, but whenever we will be applying project operation, the number of tuples will be same as the original tuple while we are retrieving the column which is behaving as a super key. So means which is unique. Super key means it is a set of attributes which is used to identify two tuples in the relations uniquely, which is used to identify uniqueness of the tuples in the relation. If you are retrieving the attributes which are from super key, then the resultant relation will contain same number of tuples as original relation. So now here if I want to retrieve super SSN, so if I want to retrieve SSN, all values are unique. So it will retrieve all the tuples. Number of tuples will be same. In previous examples, for salary session and department number, duplicates are there and department number is not primary key or super key here. So values will be deleted. The duplicate values will be removed because here there is a possibility of having duplicate values. But if it is primary key, there is our candidate key, there is no chances of having duplicate values. So the resultant relation contains same number of tuples as that of original relation. So then this is about the project operation. The next is rename operation. So rename operation is a very simple and very important operation. So this will be used while executing the complex queries. while performing complex queries. Sometimes, for example, operations like natural join operation, where we can apply natural join only if both the tables have similar column names with the spelling, it should be same, then only we can apply for such type of, that is like natural join type of operations. But if the tables have different attribute names and we want to apply natural join, what we can do in such cases, we can take the help of rename operator. And similarly, assume that I want to count the number of employees available in employee table. In the resultant table, I want to give the heading for the result as total number of employees. So I want to give new heading for the columns in the resultant table. We can take the help of rename operator. Assume that I have created a new view for a given table. A department contains thousands of employees. I want to know details of only the employees who belongs to department number 5. So then in such case, what we can do, I can extract the details of the employees belongs to department number 5 and I can keep that in the new relation. So where I want to give a special name for the department new relation. So because that relation contains only the employees belong to department number 5. So then I can rename it as, instead of department, I can rename as department 5 details. So with the help of rename operators, we can rename either attribute or the relation names, and we can use those in different situations. So now we'll see the technique to rename the attributes will be used either in intermediate results and also in resultant relations. So it will be helpful to write complex queries during join operation or union operations. Then to rename the attributes in a relation, what we can do, in the parentheses, just we can place the new attribute names. So the old attribute names will be replaced by the new attribute names, which will specify in parentheses. So now here the rename operation, as I said, it can be used either to rename attributes or the relation or both, and it will be treated as a unary operator, as we can rename single relation at a time. So we can represent it using these 3 different ways. So now here row is the rename operator. I want to, so now here this S is the new relation name, R is the old relation name. So now with the help of row, we are renaming relation name R to relation name S. So old table name is R, new table name is S. Then here within parentheses I have given B1, B2, etc. up to Bn. So these B1 to Bn are new attribute names for the relation R. So here we have renamed both relation and attributes. New name of the relation is S, new attribute names are B1 to Bn. So now here I have renamed only the table name, relation name is renamed. Old table name is R, new table name is S. What about the attributes? Attributes will be retained with the old attribute names. So here only the attribute names are renamed. So here row B1 to Bn R means relation R name R, that is table name R. We have not given any new name, it remains same, but only attributes have given the new names like B1 to Bn. So it shows that rename operation can be used to rename only the attributes or only the relation, or we can rename both relation and attributes. So for example here, I want to retrieve details of the employee belongs to department 5. So then employee, from employee table we have selected only those tuples with department number 5 and I will rename this as temp. So now this is the new table temp, which contains details of the employees who belongs to department number 5. So now the next query, whatever the query operation I want to do, for example here I want to display first name, last name and salary of the employee who belongs to department number 5. So if I apply this on employee table, then it will display first name, last name, salary of all the employees who are staying in employee table. But if I apply this on temp table, It will display only those values, only F name, L name and salary of those employees who are in department number 5. So now here the benefit of this is, assume that in employee table we have 1000 employees and in department number 5 we have only here 4 employees. If I want to apply this query on employee table, it has to check each and every row. That is 1000 employees are there, it has to check 1000 rows. This pi operation has to be executed 1000 times if I apply that directly on employee table. But with the help of intermediate table, I have extracted only employees from department 5. Only 4 employees are extracted who are from department 5. Now they are in temp. If I apply pi operation for a project operation on temp, then this it will execute only how many times? Only 4 times it will be executed. This is the benefit, one of the benefit of using rename operator to rename temporary or intermediate results. So now here what we have done, in braces, what is the new? So this we have temp, I have applied pi. So what is the resultant relation name? Name of the resultant relation is R. What are the column names? Column names is, in place of F name it comes first name, for L name it becomes last name, and salary as it is. So this is the new relation R and the column headings. So this is how we can use rename operator for renaming the operation, or that is the relation and attributes. So the next concept in relational algebra is relational algebra expressions. What do I mean by expressions here? So now expressions can be written in 2 ways. Same as in other programming language, different ways to write the instructions. Here also we can write the expression in 2 different ways. First is, assume that you want to write several relational algebra operations. Then that set of relational algebra operations can be represented as a single expression, that is an inline expression with the help of nesting the operation. So once it will start execution, it will execute the operation one by one inside the another by the help of nesting, with the help of the nesting queries or correlation. So that is here. All instructions, all relational algebra operations will be written one after the other in a sequence in the form of a inline expression with the help of nesting operations. So this is one method. So all instructions will be executed once and final result will be given after executing all the operations. So now here, first name, last name, salary of employees who work in department 5. Single expressions we will write. See, first it will select employee department 5 and then immediately that result, then on that pi operation will be applied. It will display first name, last name, salary of department 5. That is single expression we have written. In second method, what we will do, instead of writing all expressions as inline single expressions, so what we will do, we can apply one operation at a time. After applying one operation, whatever the result we are getting, we will take that as intermediate result. Then second query will be applied on that intermediate result. So here each intermediate result will be stored in a relation. Next operation will be applied on the first resultant relation. Then again after applying the second operation, we will get some result. Store that in some resultant relation. Third operation will be applied on second resultant relation. Then fourth operation on third resultant relation. Like this, we will be getting intermediate results. Then with the help of those intermediate results, we will be getting the final answer again in the form of a table. Now for the same query, so now what I have done, first we have taken apply department 5, select operation, select the employees from department 5. So those details we have stored in the temporary intermediate resultant table department 5 employees. So now apply, so this is one result, intermediate result. Again we need to apply next operation, that is pi we have applied to select F name, L name, salary. So now this will be applied on the intermediate resultant table, not on employee table. So but in inline operation, see all queries, first query, second query, third query, as many number of queries we are having, all those will be applied on single table, that is on a single relation, same relation employee. But now here, first query applied on employee table, second query applied on intermediate table, intermediate relation. See, second query applied on intermediate resultant table. If we want to retrieve again next query, again we have to apply the query on result table name result. Again for that, like this, for next each query will be executed on intermediate results. So these are the two ways to represent relational algebra expressions. One is inline expression, another with the help of intermediate results. So this is about the unary operators and relational algebra. I hope you understood project and rename operator, how to use and what are the benefits of using these operations. If you have any doubts in this, please post your question in the comment box. If you have any suggestions, you can share in the comment box. And in the next session, I'm going to discuss with you next set of operations. In last and current video, I have discussed about unary operator. In next session, we'll discuss with binary operations in relational algebra. To get those videos, if you already subscribed, you will get the link. And if you have clicked on the bell button, you will get the notifications. Thank you for now.